Hello again. After holidays, we come back again to technology lessons. I hope you have rested a lot and everybody is okay. So, everybody know what a lever is. It is a simple machine that it is useful for lifting things with less effort. So you already know some of the elements of a lever. They are the fulcrum, okay, that in Spanish is called punto de apoyo. The other one is the force, where you make the effort. The other one is the resistance, that is the object that we want to lift or to break. This is a force that is opposite to the force that we make. And we have also two other ones. The force arm, that is the distance from the fulcrum to the force. And of course, the resistance arm. That is the distance from the fulcrum to the resistance. So to summarize it, we have 5 elements: the fulcrum, the force, the resistance, so 1, 2, 3, the force arm and the resistance arm. Those are the elements of a lever. And here on the right we have some examples. We can try to identify these elements into the different examples. For example, here we have a pair of scissors. It is easy to discover that this point where the two handles of the pair of scissors rotate is the fulcrum. Okay? Here could be the piece of paper or the object that we want to cut. So this is the resistance. We are going to make the effort, the force, here in the handle. So here we have the force. Now we are going to indicate what the resistance and the force arm are. We need to indicate the fulcrum and the distance from the fulcrum to the force. This is the force arm. The distance from the fulcrum to the resistance is the resistance arm. Okay, so we have identified all the elements in the first example. Now we need to decide what class of lever is this. So here we have the force, the resistance and the fulcrum. Which one of these elements is in the middle? So this is the fulcrum. The fulcrum is in the middle. If you have the fulcrum in the middle, the class of your lever is number 1. Okay, this is the definition. It's a classification for levers. In the second example, we have a wheelbarrow. It means a carretilla. Where is the fulcrum here? It's easy to understand that the point where the lever rotates is the wheel. So the wheel is the fulcrum. Where is the weight that we want to lift? Here in the middle. And we are going to make the effort on the right. So this is the force. Which one is in the middle? The resistance. And if you have the resistance right in the middle, the class of your lever is number 2. Be careful while indicating the force arm and the resistance arm, because the fulcrum now is not in the middle. So this is a bit tricky. So the force arm could be from the fulcrum to the force. This is the length of the force arm. And the resistance arm is the distance from the resistance to the fulcrum. This is the resistance arm. And it seems easy, but after, while doing problems, while trying to solve problems, many people make mistakes. So pay attention to that. Here we have a nutcracker. The nut would be here. Okay. So here you have the fulcrum. The nut, of course, is the resistance, and the force is also on the right. Similar to the previous one, so number 2, the resistance is in the middle. Okay? And the same disposition, the same location for resistance arm and force arm. I'm not going to repeat that, okay? Here we have a fishing rod, una caña de pescar. And here would be our face, okay? You have the 2 hands holding the fishing rod, but you have here an arrow. It means this is the hand that is making the effort. So this is the force. This is only for supporting the fishing rod. So this is the fulcrum. And the resistance would be the fish, but the fish is pulling, so the resistance can be indicated there. What is in the middle? The force. And if the force is in the middle, the class of your lever is number 3. Be careful again while indicating resistance arm and force arm. Force arm or resistance arm. Previous. Okay, so from the fulcrum to the resistance, you have the resistance arm. From the fulcrum to the force, you have the force arm. I hope it is clear, okay? Once we have reviewed that, we need to study 2 important formulas. The law of lever, la ley de la palanca, it says that a lever is balanced when the force arm, force times the force arm equals the resistance times the resistance arm. When I mean that a lever is balanced, I mean that tengo una palanca en equilibrio, okay? The force need to be expressed in newtons, okay? So its symbol is N. The force arm need to be expressed in meters. The resistance is also a force, so you have also newtons, and the resistance arm would be also meters. This is the most important formula for levers, okay? And you need to pay attention on the unit, otherwise you are going to make mistakes. But sometimes we speak about mass. For example, here the sand that is trying to be lifted by the wheelbarrow can be expressed in kilos. We have 50 kilos or we have 100 kilos. Kilos is mass, is the unit of a magnitude that is called mass, la masa. And we need to be able to convert mass into newtons. For doing that, we are going to use another important formula. Force equals mass times acceleration. But while speaking about weights, about peso, we are going to use the acceleration of the gravity. So the force needs to be expressed in newtons, the mass into kilo, and the gravity is going to be 9.8 meters a square second. Okay, so this is the other formula, important, crucial formula for solving the problems. Once you understand that, we are going to solve some examples. Okay, here we are, an elephant and an ant, un elefante y una hormiga. We are going to follow some steps that are going to help us to solve the problem. So the steps are: 1. Draw the lever. Here we have the example. Number 2. Identify the position of the elements. Okay? If you notice, we have not even read the problem. We have drawn the lever, we have identified the position of the elements, and now we are going to try to extract the information, the data, okay? Extract the data. Number 4, we are going to pay attention on the unit. On the units. Above all, we need to convert kilos into Newton and centimeter into meters. And finally, number 5, we are going to apply the formula. But this is not the first step, it's the last one. Okay? So try to apply those steps with the example. The element in the picture, the elephant of the picture. Okay, draw the lever, identify the position of the elements. We know that this is the fulcrum, but we don't know if the elephant or the ant are the force or the resistance. For doing that, we need to read the problem. The elephant in the picture weighs 300 kilos. And the length of the arm on which he's standing is 50 centimeters. The ant weighs 1 gram. What should be the length of the arm that the ant is standing on in order to lift the elephant? So this is the clue. The ant wants to lift the elephant. So the ant is the force. And the elephant is the resistance. We can say that this lever is a class 1 lever, so it means this is the resistance arm, and this one would be the force arm. So we have drawn the lever, identified the position, extract the data. So we are going to write here data and procedure. To extract the information, we are going to write force, force arm, resistance, and resistance arm. And we are going to read it again carefully. The elephant in the picture weighs 300 kilos. So this is the resistance, 300 kilos. But we have a problem. The resistance needs to be expressed in newtons. So we need to use the formula force equal mass times gravity, and gravity is 9.8. So 300 kilo times 9.8 meters square second is going to be the resistance. Okay, what else? We can know this. Okay, what else? The length of the arm on the elephant is standing is 50 centimeters, so it means that one. 50 centimeters is 0.5 meters. And the solution of this is 2,940 newtons. What else? The ant weighs 1 gram. Okay, 1 gram needs to be converted into kilos, so we have 0.001 kilos. And again we have kilos and we need newtons, so we are going to multiply it times 9.8, and we have 0.0098 newtons. And the unknown value, la incognita, is the force arm. Okay, so, and it would be expressed into meters. Once we have everything and we have paid attention on the units, we are going to apply the formula. Force times force arm equals resistance times resistance arm. And now we have all the elements, so we can substitute the values. Force arm equals that. Force arm finally is that. And the solution is 150,000 meters. So this is the solution. You have finished. But if you want to make sure that you understand it well, we can convert this into kilometers. It means the ant need a lever with a 150 kilometers long force arm to be able to lift the elephant. Awesome! Okay, if we move to another one, we can see here a rower. The rower in the picture can provide a force of 250 newton to each oar. It means el remo, a cada remo. The length of the force arm is 60 centimeters and that of the resistance arm is 120 centimeters. What force does each oar apply to the water? So we have drawn the lever. We have here the fulcrum. This is the fulcrum. This is the resistance and this is the force. So this is a class 1 lever. This is, of course, the force arm, and the other distance is the resistance arm. Once we have everything clear, we are going to extract the data. Again, we write force arm, resistance arm, and we are going to focus on this detail. Each oar. I mean, you are looking for the force in each part. So you are going to take into account only the force that you make in one of the oars. Okay? So the force is 250 newtons. The length of the force arm is 60 centimeters. It means it's 0.6 meters. The resistance arm is 120 centimeters, so it means 1.20 meters, and the force that each oar applied to the water is the resistance. So once we have here, we can write procedure and apply the formula. This is simple. And the solution, a moment please. The solution could be 125 newtons. And that's the resistance of this problem. And the last one, I promise. So we have here an strong boy. A top-level weight lifter can generate 3,000 newton of force. This is the force, this is the fulcrum, and of course this is the resistance. So we're going to indicate again the force arm and the resistance arm. We have everything ready. Extract the information, data, force arm, resistance arm. And now we are going to read it carefully. A top-level weight lifter can generate 3,000 newton of force. What is the maximum weight? Be careful. They are asking us to express it in kilos instead of in newton. That he would be able to live with a force arm of 2 meters and a resistance arm of 50 centimeters, that is 0.5 meters. And it says, remember that in order to change mass into force, you need to use the formula. Okay, we already know that. We are going to calculate firstly the resistance into Newton, and after we are going to convert it into mass. So the procedure will be the formula, the law of lever formula. Force times force arm equals resistance times resistance arm. So 3,000 times 2 equals R times 0.5. The solution would be 6,000 over 0.5, whose solution is 12,000 Newton. But we have not finished yet. We need to convert it into kilos. So we are going to divide this into 9.8 to get the final solution. Okay, so it would be, just a moment please, and the solution is 1,224.5 kilos. And now this is the solution. Okay, I hope you have understood everything. You can watch this video as many times as you need, and after watching it, you need to do the exercise by yourself and answer the form. Bye bye, be lucky.